Hello everyone, this is Madam Lee, and now we are going to talk about the area and volume of similar figures and solids. It is related to the previous section on congruent and similar triangles, but in this portion, we have moved on from triangles and we are going to talk about different kind of shapes. So let's start with areas of similar figures. Now, in this section, it is a little activity for you to find out the relationship between the ratio of the sides and the ratio of similar figures area. So let's start with the most basic square. In this inquiry activity, the sides of this small square is 2 cm by 2 cm. So the area of the figure, we can say that it is 2 times 2, and therefore it is 4 cm squared. Okay, now if you look at the big square, each side is 4 cm, and therefore the area of the figure is 4 times 4, which is 16 cm squared. Okay, now, so if you look at the ratio of the length 2:4, we can simplify this into 1:2. So this we are looking at length. Now when it comes to area ratio, look at the 4:16. Again, we can simplify 4:16 by dividing each side by 4. If I do that, I'm going to get 1:4. So this is for area ratio. So to conclude, the ratio of the areas of any two similar figures is equal to the square of the ratio of any of the two corresponding lengths of the two figures. So if you look from length to area, okay, from length, this is what we had. If I square both sides, this is how I'm going to get 1:4, which is the area ratio. Okay, so therefore the conclusion. In fact, we have seen something similar before under the chapter of math skill, where they gave you a ratio, a distance ratio, and for you to find actual area or the area on the map, you have to convert the distance ratio by squaring both sides. Okay, so you should have learned something about the squaring of the ratio before in lower sec. Okay, so if we were to write this conclusion, the first conclusion in our mathematical formula, we can say that area 1 over area 2, okay, if they are similar figures, they have to be similar, then we can use their corresponding length ratio, square the length ratio to obtain the area ratio. Okay, now let's look at the surface area instead of just area, okay, of similar solids. So when we talk about solids, we are talking about 3D diagrams. Whereas when we talk about figures, we refer to 2D diagrams. Right? Okay, so in this case, they want us to find the surface area of this cube. So if we look at the smaller cube, the length of the side of the smaller cube is 2 cm. Okay. That means that the area of one face of the cube is 2 times 2, square. And when it comes to total surface area of a cube, how many surfaces will there be? So if we count the cube, there are a total of 6 surfaces. 1, 2, 3, 4, 5 at the back and 6 at the bottom. So I can say that it is 4 times 6, and the total surface area will be 24 cm squared. Okay. Now if you look at the big cube, it is given that the length of one side is 3 cm, and therefore the area of one face of the cube will be 3 times 3, and therefore 9 cm squared. Again, there are going to be 6 sides because it is still a cube. So therefore, the total surface area is 36 cm squared. Now, if we look at the numbers to conclude, you can see that the ratio of the total surface area of the smaller cube, which is 24, is to the total surface area of the big cube, which is 36. Again, this ratio can be simplified. We can divide both sides by the highest common factor, which is 6, and therefore we can obtain a ratio of 4:9. Now, if you look at the number 4:9 and compare it to the length of the side 2:3, again, the surface area of any similar solid, okay, so of course they have to be similar first, is that it is still equal to the square of the ratio of the corresponding length. So what it means is that if you look at the length ratio 2:3, if I were to square both the numbers, I will obtain my area ratio of 4:9. So it doesn't matter whether the area ratio we are talking about is just for one face, a square, or for the entire surface area as shown in our little inquiry activity at the top. Okay. So again, to conclude, in a mathematical formula, we can write that the surface area of two similar solids is the corresponding length squared. Okay, and actually, if you look at this formula and the one that we have previously concluded, they are actually the same. So as long as we have to look for similar area ratio, we can use the corresponding length ratio with a square to obtain the similar area ratio. Now in the next section, Madam Lee is going to go through a few examples to show you how we can apply the formula to application questions.